When we're working with large language models, often we're going to describe in our prompt a set of rules that we want the large language model to follow. Rules that are going to affect its output and essentially program the large language model. And one of the things that we're going to want to do is we're going to want to say, here are the rules, now apply them to an input that I'm going to provide later. And so one of the challenges is, how do we get the large language model not to immediately respond to all of our rules? If we have a flipped interaction, for example, sometimes when we flip the interaction and we say ask us questions, it'll generate 10 or 20 questions all at once. And so what we want a way to do is basically a simple way that we can get the large language model to listen to what we're saying, acknowledge it, and then wait for input from us. Now, we can do this with the ask for input pattern. So the idea behind this is we want to get the large language model to listen to the rules and then ask us for the input to apply the rules to. So when we're talking about asking questions in a flipped interaction, we might want to describe the rules for asking the question, and then we just want it to ask one question. So we just want to get one question out. If we're describing rules for alternative approaches, we might want to say, here are the rules. You're always going to create alternative approaches to whatever I ask you to do, but just ask me now for the first task to create alternative approaches for. We don't want it to go and have a big response to it. And what we see is that that's not always the case. So let's take a look at this example. Now, in a prior video, I introduced the alternative approaches pattern. And when you saw me use this pattern, it worked really effectively because I was actually combining it with the ask for input pattern. So I'm going to show you what it looks like when I don't combine it with the ask for input pattern. So I went and I said, whenever I ask you to write a prompt for me to accomplish a task, list what the task is, list the alternative approaches for creating the task, and then write a prompt for yourself for each approach. So I'm asking ChatGPT, give me a bunch of alternatives for prompting you, ChatGPT, to solve the task. So this is going back to the earlier idea where I showed how we could actually use ChatGPT to generate prompts for itself, to help us with prompt engineering. And what I do is I use this, but I'm taking away something important that I'm going to show you in a minute. And what it does is ChatGPT responds, it says certainly, but then it dreams up a task. It says, here are 3 alternatives for completing the task, organizing a cluttered desk. I'm not interested in the task organizing a cluttered desk. It just responded to my initial prompt, which was create alternative approaches for a task. It dreamed up a task and then dreamed up its own approaches for that task. Now, I'm not interested in this, so now I've got my conversation and it's got all this extra stuff in it that I don't care about. I had to wait for it to generate it. And if I was trying to create some interactive experience that had some consistency, this would not be helpful. So what I can do is I can apply the ask for input pattern. And the idea behind this is we just do one simple thing, and that is at the end of the prompt, we tell the large language model to ask for the next input. So in this case, we say, ask me for the first task. So the very last thing we do, we describe all the rules or whatever it is that we want in our prompt, and then the last thing we do is we said, now ask me for the first task. Ask me for the first idea. Ask me for the first thing you want me to generate a story about, whatever it is. But it's a way that we can sort of cut off the large language model and tell it, don't go generate a bunch of stuff. I'm glad that you can do that, but what I want you to do is I want you to stop right here and ask me what I want to do. So it's a way of forcing the large language model to basically turn the control back over to the user and let them decide what to do next. Now, like all prompt patterns, when we're dealing with a large language model, it is somewhat stochastic or random. It means it's not always going to do exactly the same thing every time, and it may not work 100% of the time, but this works very, very reliably to just say, ask me for the first input or whatever it is at the end of the prompt, because it clues the large language model in that it needs to stop. And if we look at the comparison of the output, it's actually much more focused. So we see in this case, it says, certainly, let's begin. What is the first task? you would like me to create alternative approaches and prompts for, rather than this much longer thing that it generated before that was not really helpful to what we were doing. So it kind of cuts it off. Notice it's the same input, but it's sort of cut it off. It's told it, look, you need to stop right here, and you need to wait for my input. One of the things you may have noticed that I've started doing is I've started combining patterns together. And this is going to be one of the most important concepts when you want to build really sophisticated prompts, is you need to think through how to apply multiple patterns in conjunction with each other in order to solve the problem that you're dealing with. So rather than just thinking about, okay, which pattern can I use to solve this problem? Instead, what you want to think about is, okay, which pattern will solve certain aspects of the problem, and how would I combine those patterns together? And we started to see an example of this with ask for input and alternative approaches. Ask for input is a pattern that can be applied with a lot of other patterns. In this case, we're applying it in conjunction with ask for their provide alternatives. And so we've got alternative approaches and we've got ask for input, and they're being put together to build a prompt that's solving the overall problem. Now, what we're going to see throughout this remainder of this course is that this is the way we build really, really sophisticated prompts, is to think about taking multiple patterns and combining them in interesting ways. Now, if you think back to some of the patterns that I introduced in the course and some of the examples I gave, now that you know more of the patterns, you'll probably see that I've actually been combining patterns all along in different examples. So in gameplay, for example, I probably used ask for input. And in gameplay, I used probably the persona pattern. And so you can see how putting things together helps us solve the overall problem. And so when you're going and you're trying to tackle some new complicated prompt that you need to engineer and develop, you want to think about, okay, what are sort of the fundamental pieces to this problem? And do I have existing patterns that I know about that I can use to hopefully tackle all of it? But if I can't tackle all of it, can I use patterns and apply them to as many different pieces as possible so that your unknown piece that you really have to start from scratch and invent something new, that it's as small as possible, that we can start with as many pieces as possible with a roadmap for them, a pattern to apply. And so that's what we're going to be doing. Now, it may start to seem more complicated than it is, but at the end of the day, what we're still doing is we're still building up language, right? We're still writing in natural language. We're still writing sentences. We're still communicating. We're just thinking intentionally about the patterns in our language. And we're thinking about what are the statements in the organization of those statements in order to solve the problem. And so in some ways, combining patterns is really doing a more powerful version of programming. We're starting to take different sort of programs or instructions that we know how to use and put them together in more complex and sophisticated ways in order to have prompts that have more power to them, that have more depth to them. And again, you know, don't feel that this is something you can't do. Everybody can do this. At the end of the day, think about it. You're just describing in words what you want done. You're still describing in language what you're trying to accomplish, and all this is doing is helping us think about what should go into the instructions. If we're going to use this pattern, it's giving us a set of commands, a set of statements that we need to include, and sort of an organization for them. If we're going to use this pattern, we're going to have a set of statements that we're going to include. And oftentimes putting things together is simple as just taking the statements from each pattern and making sure they all show up in the prompt. Sometimes it's that simple. Sometimes it's more nuanced, and we may need to make sure, you know, a certain statement ends up in a certain place. Like with the ask for input pattern, we probably always want the ask for input to show up at the end of the prompt, because otherwise it doesn't work nearly as effectively. So although putting patterns together can be a little bit tricky sometimes if you have to figure out where things should go, most of the time it's as simple as putting the statements together. So as we go through the rest of the course, what I would encourage you to do is to notice when I'm using multiple patterns together to solve a problem, and to think about, as you're trying to tackle new tasks with prompt engineering, how to use multiple patterns in conjunction with each other to solve the problem. there's a limit to how big we can go with the large language models. They fundamentally have a limit to the size of the input we can give them, so how big of a prompt we can give them or how long our conversation can be and they can still remember it. And there's just a limitation on how much output they can generate at once. Now, it's inevitable that these language models are going to keep getting bigger and bigger, and we're going to be able to give them more and more input and get more and more output from them. But more than likely, everybody is going to face some limitation on how big we can go. Now, the way that we work around that is we're typically generating pieces. Like we generate a piece of the solution, then we take it. So you can imagine if you're trying to generate a book, you can't just tell ChatGPT at this point, go and generate a book for me. It's not going to do it. It's going to tell you, well, I have to stop my endpoint at some point. And similarly, you can't just give it 50,000 pages at this point and dump it into ChatGPT and ask it to give you an answer, or 100,000 pages or 1,000,000 pages. There's always going to be a limit, probably, on the amount of information. So we need a way to work with it in smaller pieces, but still be able to put all the pieces back together. So one of the ways that we can do that is by building an outline of what we're trying to put together. And we can build the outline out, we can build it to the level of granularity that we want, and then we can start filling in the pieces once we've gotten enough detail into our outline. And then we can go and generate individual pieces, and we can know where they all fit together. So this is an effective way of using it to generate the pieces. Now this is basically putting a plan together. This same approach works for all kinds of things. It could be software, anywhere where we can go and sort of have this outline-like structure, and then if we generate something that fits sort of the outline or the plan at that point, then we can go and work with it. Now we're going to look at a specific pattern that can help us generate the outlines and work with them. This is called the outline expansion pattern. And so the idea is we want to make it really easy to generate outlines and continue to expand them down to the level of granularity that we need in order to build the individual pieces and then be able to put them together. Now, one of the reasons that outlines are a really helpful tool when we're building bigger bodies of work with a tool like ChatGPT is that an outline, we can always take parts of the outline and copy and paste or reintroduce them into the prompt to give the large language model context about what we want. So with ChatGPT, for example, we can generate an outline and then we can copy and paste a portion of the outline into our prompt and say, within this context, here's where you are in the outline. Now fill in the content for this and don't repeat anything that would have come before in the outline. And in fact, you can refer to the other parts of the outline wherever you're going to talk about a topic that was discussed previously. Or maybe we want to have forward references where we can provide at the high level outline and say, wherever you are going to need to talk about a topic that's going to be discussed later, you can provide a forward reference to where it is in the outline. You can do similar types of things with software or other sort of whatever the bigger thing is that you're building. Now, this works well when we have a structure that's amenable to sort of this outline-based plan. Now, sometimes we have plans or structures or designs where everything crosses over and you can't easily do this. It doesn't work to express it as an outline and express the plan, and in those cases, it just doesn't work. But many problems we can sort of build out in a sort of outline-like fashion, and then we can use cutting and pasting from the outline to provide the appropriate context. So building outlines can be a really powerful thing for us. So we're going to look at and build with the outline expansion pattern. So here's what we say. We're going to say act as an outline expander. And notice I'm starting to introduce multiple patterns here. I'm basically introducing the persona pattern. Generate a bullet point outline based on the input that I give you, and then ask me for the bullet point you should expand on. So we're telling it you're going to generate the outline, and then you're going to expand on anything that I ask you to expand on. Create a new outline for the bullet point that I select. At the end, ask me for what bullet point to expand next. So notice I'm using the tail generation pattern as well, and then I'm using the ask for input pattern. So I'm putting a lot of things together into this prompt. And I say, ask me for what to outline. And so what we see is it says, sure, I'd be happy to help you with that. So I say, let's write an outline for writing effective prompts for ChatGPT. And so what we see is that ChatGPT generates this outline, and it's an interesting outline: introduction to ChatGPT, understanding the importance of prompts, tips for writing effective prompts, yada, yada, yada. So a lot of good things there. And then I decide, okay, let's go and expand on 3 from the outline. So if we look back here, 3 was tips for writing effective prompts. I thought, let's go ahead and expand the outline there and explore this a little more. And so then it picks up from 3 and it expands on tips for writing effective prompts and gives us a new outline. So we built, in using this pattern, we can rapidly fill in an outline, and probably there are going to be tools to support us in this very soon, or plugins to support us in this very soon, to where we don't have to remember all the pieces of the outline. With this, I would probably just manually have a document where, as it was generating the pieces, I would go and look and say, okay, here's the 3. I'll paste 3 in its expansion now, and you can easily fit the parts together. This is one of the nice things about the outline approach, is that it's really obvious how all the pieces fit together. I know that 3.1 goes underneath 3, so it's sort of self-describing in terms of the assembly. So if I generated a piece of an outline here, I've expanded 3, I know exactly where that goes, how it fits together in the overall whole. Then I go and say, well, you know, this idea of experimenting with different prompt styles, that looks interesting. So maybe I should go and expand that further in the outline. And so I basically say 3.2, and now it goes and expands the outline around 3.2. So you see how we've got a simple pattern, and we now can go and rapidly create an outline and keep expanding it to the level of detail. And because of it's using this outline structure, it's really easy to fit all of the individual pieces back together. And as long as we have limitations on how much input, how big of a prompt we can give, and how much output we can get at once, we're always going to be looking for ways to generate things in pieces and know how they fit together. So we want the pieces to be really obvious on how to assemble them, and we always want to make sure that we have a clear structure or set of guidelines for each individual piece so that we can assemble them. So you can imagine if this part of the outline depends on knowledge of what was covered in a different part of the outline, then we would need to make sure that that was introduced into the prompt. So we just said 3.2, but if we had an idea that maybe the conversation had gotten so long that what was in item 1 had been forgotten, we might want to go and just cut and paste the outline underneath 1 back into the prompt and then say expand 3.2, because we know 3.2 was just previously generated, but that would help give it the knowledge of what had come before and make sure that what it put into 3.2 was consistent with what had been done earlier in the overall structure. Similarly, if it needed to make sure that 3.2 was cohesive with what's going to come later, we would want to put in those pieces. So one of the things we have to think about is, even if this outline style, when we do this, it will work, but we always have to think about, you know, does it still have the context to make sure the individual pieces are cohesive, even if they fit into the outline at this point? We want to make sure it doesn't do something that, you know, breaks something somewhere else. And this is a problem, a fundamental challenge that we're always working with in prompt engineering when we're building from pieces. How do we build the pieces so that they're standalone, self-contained, but can be assembled into the overall whole? And so we see this again, we just expand 3.5, which was setting the tone and style. And we get this very rapid expansion and creation of a sophisticated outline now that we can use to write text for a bigger project, to be able to try to write software. There's all kinds of sort of analogies or analogs to the outline, the sort of the master structure, where we start with a certain level of detail, then we pick some piece of it and we expand the level of detail. And then we may pick a piece of that and we may expand the detail. And then we may move back up to another bullet point in the outline and expand the level of detail. And so we can be moving up and down in the outline. We can be going up to the top level, or we can be going down to the really detailed things, and we can expand wherever we want and sort of keep a map of the overall picture that we can use to build individual pieces and make sure that we can assemble them. But also, as we build pieces, that we can make sure that ChatGPT has the relevant information, the sections of the outline, for example, in the prompt that it needs in order to reason about or generate whatever it's going to produce next. When we're working with computer software, one of the things that's really useful is that programs typically have some menu with a series of actions that we can apply. So if you've ever used word processing software, there'll be like a file menu that allows you to run an action to open a new file or save a file. You may have a menu that allows you to search and replace different pieces of text. So this idea of having a menu and different actions that we can run is a really useful concept. And sometimes when we're working with prompts and prompt engineering, and particularly when we have a long conversation, it can be helpful to sort of develop the equivalent within a prompt. Basically define a set of, essentially a set of actions that we can run in order to work in the conversation without having to repeat these long prompts. Or we want to just sort of codify certain actions that are helpful to people and bake them into a prompt at the very beginning of the conversation. So let me give you an example of this. We're going to look at using the menu actions pattern. This is a pattern that allows us to get the same type of behavior but in prompts. So we're going to develop a menu that is a series of actions that we can run, and actions are basically, essentially a prompt. It's basically a set of instructions that we're going to give the large language model in order to do something at a particular point in the conversation. So here is how this works. We describe what we're going to type in order to trigger the action. So I say, whenever I type write bullet point paragraphs, and let me talk about this in more detail in a minute. So don't worry if this seems just doesn't quite make sense yet. So whenever I type this phrase, write, and then I have in less than, greater than, bullet point, and then paragraphs, these are placeholders. So basically I'm saying I'm going to type in write, and then a placeholder for a bullet point, and then a placeholder for a number of paragraphs. You will write content for the selected bullet point. So basically what I'm saying is I'm going to give you a bullet point that you need to go and write the content for. And then I'm going to tell you how many paragraphs of text to write. And then you're going to go and write the text. So basically I'm developing an action which is, before all I could do was expand my outline. So when I talked about the outline expansion pattern, I talked about being able to rapidly expand the outline. And now what I'm going to say is at some point I'm going to be able to tell you, no, go and turn that into text rather than just outline. So I'm creating a new action. I'm also going to go ahead and keep my original action, which is just expanding the outline. So I say whenever I type, and I have a placeholder for bullet point, you will expand that bullet point. So what I'm saying is if I just type in like 3.5.2, which is a bullet point, like a number in my outline, it'll know that it means expand that in the outline. If I instead say write, which is kind of a keyword, and then a bullet point and a number of paragraphs, it knows that that means it's supposed to write the text for it. So I'm defining a menu. I now have two actions. I can either expand my outline or I can write the text for part of my outline. And so now I'm developing more sophisticated capabilities for my outline expander. I'm turning it into a real program now, something that I can interact with. So let me show you an example. Now here's my first action being run. I'm saying write 3.5.3 2. Now what that means is write the content for the bullet point that was labeled 3.5.3, so label 3.5.3, you're going to write the text for it, or for that part of the section in the outline, and you're going to write 2 paragraphs. And so what we see is it takes the bullet point 3.5.3 from the outline, which was experimenting with tone and style variations. It then writes 2 paragraphs of text for that bullet point. So I've created an action, I've defined it, and I've created a menu of actions and I've defined it in my prompt, and now I can run that action and get the text generated. And so then we see it prompts us again, what do we want to do next? So this is actually not part of the text it wrote. So it did write 2 paragraphs, then asked me what I want it to do next. So then now I'm going to go back and I'm going to do exactly what I did before. I'm going to say expand on 3.5.2. So this is what I did before, and now it knows the difference, and it knows that's a different action. And so it goes and expands 3.5.2 and puts the outline for it again. I then go down and I say, okay, give me text for 3.5.2. And notice something kind of interesting. I'm actually making a typo here, but it's kind of being smart in inferring what I'm supposed to do. And this is kind of an interesting thing, is it's a very sort of, it tries to help you out, tries to get things right. And it knows based on the pattern that what I probably meant was write 3.5.2. Instead I wrote text. So it's kind of a smart menu action system. And then it actually goes and it pulls in that bullet point, 3.5.2.3. Sorry, I said that wrong. It's 3.5.2.3. And then it writes one paragraph of text. And so I've created basically a complex program where I can expand my outline if I want to, or I can have it write the text for a part of the outline, but I don't have to repeat myself. I get to use this simple little format, and I've explained what the format is, and now I can rerun the actions whenever I want to. So one way this is useful to me is, like, if you're doing the same task over and over with prompts, it can be helpful to use the menu actions pattern to basically define a set of actions on kind of like on a menu of a prompt that you use all the time. And then whenever you want to iterate really quickly using that content and those set of actions, you can just introduce that menu actions prompt and then go and use those actions over and over on the output that you're getting in order to manipulate it or do something. You've basically built yourself your own program within the conversation. At the same time, sometimes an organization may have, a number of people that are doing the same job, and they can share actions with each other to help automate different tasks. And so this could be really useful to help people be more effective with their jobs and to share with each other useful prompts. The other thing is you don't have to worry so much about remembering exactly how you worded it, right? Once you've written the action once and gotten it to work in the menu, then you can reuse it over and over without worrying about, not quite getting it right when you do it. And then that leads into a final thing that's really useful about the menu actions pattern, is that within an organization, you can share a set of common menu actions that everybody should use, and you can codify the best, wording for those prompts and for those actions and what they should do, maybe codify best practices into them, and then share them across the organization. So it allows for knowledge sharing and reuse of different prompts and an easy application of those prompts. You could also imagine baking these into a root prompt for something like a customer service portal where you want to give people certain actions they can run to look up information about their account. They could do it in natural language, but you could also describe, here are some actions you could run, and allow them to get better behavior out of it. So the menu actions pattern is a really powerful pattern that allows us to easily reuse other prompts and actions that we've used to share them with others and develop knowledge bases of them so that we can become more effective prompt engineers. We've heard over and over in the news that these large language models make all kinds of mistakes and can lie to you, and they'll never admit their mistakes in the first place, and they'll keep telling you they're right and produce weird outputs. And of course, this fundamentally kind of misses the point of the tool. These aren't meant to be tools for answering questions necessarily. Now, sometimes they can answer questions and do it very accurately. And sometimes they produce things that look like answers but aren't actually accurate. And so as long as we understand they're really for generating text, and sometimes the text they generate can answer things for us correctly, and sometimes it's going to make mistakes, as long as we realize that, we can use these tools effectively. Now, one thing we can do is we can use prompts to support us in our identification of what are the facts that the tool is putting into its output and which of those facts really matter. And we can go and then follow up on them and check them. Now, one of the things that happens sometimes when we're working with output from these tools is that because the output looks so realistic, so human, so convincing, we assume that it's true. And when it's producing large volumes of text, it can be hard to spot all the different assumptions and facts that are baked into the text that we really need to follow up on and fact check. Anything you get out of one of these models, you need to take ownership of and make sure that you've checked it thoroughly and really believe it. What do we do to support us in this effort of trying to make sure the output is correct and factual? Well, we can use the fact checklist pattern to help us figure out what facts are actually in the output and need to be followed up on. So I'm going to give you an example of this. So I've taken our outline expansion tool. And if you remember, we used a couple of different patterns, including the menu actions pattern. We used the outline expansion pattern. We had several different capabilities. One of the things we could do is we could go and expand the outline. We also added the ability to be able to generate text for any bullet in the outline. And we can generate for a number of items. And we had a whole menu system to be able to do this. Now, one of the things we'd like to be able to do is when we do generate text for part of the outline, I'd like to know what I need to follow up on and fact check at that point in order to make sure that I don't present information that's inaccurate. So if we look at this, the way that we can do this is with the fact checklist pattern. We say, whenever you output text, generate a set of facts that are contained in the output. The set of facts should be inserted at the end of the output, and you could put them wherever you want. I'm just putting them at the end. The set of facts should be fundamental facts that could undermine the veracity of the output if any of them are correct. So I'm setting up a new set of instructions for the large language model that says, anytime you produce text, give me the corresponding set of facts that the text depends on. And that's the way I can go and follow up on them and check them. And so it says it understands. And so now I'm going to use our outline expansion program that we've written. I'm going to tell it to write a paragraph for section 3.5.2.2. So this section is considerations for choosing the appropriate style, and it generates a whole paragraph of text for me. And then what it does is it generates a set of fundamental facts down here that are the facts that are contained within the paragraph. And so the facts are, for example, writing style can range from technical to creative to instructional. There are other things like instructional content may adopt a clear and step-by-step style. Now this paragraph that I chose for it to write, it has a lot of different facts that maybe they're correct, maybe they're not, but it's not something that I have to worry as much about going and extracting and just staring at text, because I now have a list of things to follow up on. At a minimum, I need to look at this list and follow up on these items, or just actually visually check them myself for my own knowledge. That's sort of the minimum level. Now I have a minimum bar. At least these things I need to go and follow up on, and it's sort of flagging to me, here are some things that you need to go and check. The other thing I can do is I can compare this list to the paragraph up here. So any person that's probably using one of these tools can compare, here's the list of facts below, here's the actual text above. Is the list of facts complete? Are there statements in the text above that are missing below? And if there are, those are probably things that I would want to go and follow up on as well. And so by checking and comparing the two lists, one, we can see, is it really fully extracting all of the facts that are important? And that in itself will clue us into and make us think through, what is this really saying and what are the fundamental facts to it? So just the sort of the action of going and comparing the facts to the text it's produced will help us get us into the mode of thinking through the correctness of what it's produced. The next thing I can do is I have a minimum bar. At least I need to go and check up. At the very minimum, I need to go and check the list of facts that it produced and follow up and make sure that they are correct. And if any of them is incorrect, then probably there's an error in the text above. And then if I notice that there's something in the text above through this comparison that's also not present in the facts, I could add that to my list and go check it. So this is a tool that can help us, get into the mode of fact checking the output. It may be correct, but we still don't know for sure until we actually fully follow up on it. And this gives us some tools to help us, one, know that there are things to follow up on, at least follow up on these things, and then two, to help us give us a tool that we can go and compare to what it produced to see, is the minimum list of things that I followed up on good enough, or are there all other things that are in that text that maybe I should think through or follow up on? Now, it doesn't guarantee that we're going to come up with the right answer. We might think that it's still accurate when it's not, even if we follow up on those facts. There may be some hidden assumptions, but it's much better than if we just read a bunch of text with no sort of support or stimulus to think through the fact-checking process. So this is the fact checklist pattern is something that helps us get us into the mode of checking the output, checking its veracity, and having a format that makes it easier for us to sort of extract and compare the information and the sets of facts with what's really true using other external sources. When we're having a long conversation with a large language model, sometimes we'll run into the challenge that the large language model will forget the rules of the game. It'll forget what we're trying to accomplish. What is the task that we're working on? And so one of the things we need is a way to remind the large language model, what are we doing? And we'd like it to remind itself if possible. And so the way that we can do that is by using what we call the tail generation pattern. And the idea behind this is that we're going to generate a tail, an end to the output that the large language model produces that will help remind it what we're doing. And so the tail is going to always be generated at the end of its output, and the tail will remind the large language model what the rules of the game are. And we're going to see this in the context of combining the tail pattern with the alternative approaches pattern and with the ask for input pattern. So we're going to put all these things together, and we're going to see how this is a really useful thing. So generating a tail on our conversation using the tail generation pattern is really, really effective in maintaining our conversation longer and maintaining the rules and the knowledge of our rules longer. So I've actually used this several times, and I haven't talked about it, but I'm going to show you what it does. So this is the prompt that I used in the alternative approaches pattern discussion. So I'm asking ChatGPT to generate a set of prompts to solve a particular task. So I'm asking ChatGPT to help us with prompt engineering. I'm going to give it a task, and it's going to generate possible prompts that we could use to perform that task with ChatGPT. Now, if I do this over and over, and I keep saying anytime I ask you for a prompt, you should go back and generate multiple alternatives for it, the problem I'm going to run into is that eventually it's going to forget that it's supposed to generate a bunch of alternatives and that it's supposed to be generating prompts. And so I need a way that keep reintroducing that rule into the conversation to keep it alive longer. And so one way I can help do that is with the tail generation. And so this is the tail that's being generated. I have the prompt and I say, when you are done, ask me for the next prompt to create alternatives for. So I'm adding this on. I'm saying when you're done, at the end of your output, you're going to ask me for the next prompt to create alternatives for. So notice what I'm doing. I'm actually using the ask for input pattern. I'm saying at the end of the input, at the end of the output that you produce, you're going to ask me for the next input. So you're going to ask me for the next task to accomplish. And I'm telling it, you're going to ask me for the next prompt to create alternatives for. So I'm also reintroducing the rules of the game. I'm describing what the purpose of the input is that I'm going to be giving it and what it's supposed to do with it. And I'm making sure that this shows up at the end of my prompt, at the end of the output that the large language model is going to produce. So I've defined the rules and I've said at the end of what you do, you're going to reintroduce this rule by basically asking me for the next input to create alternative prompts for. So let's see what happens. So I add this tail on, and so I'm generating a tail. I'm using the tail generation pattern, and I say, write a prompt for ChatGPT to automatically detect questions in a chain of emails and summarize everyone's opinions on the question as bullet points beneath each question. So I've given it the task. Here's what I want you to write me some possible prompts for. So I would give it the instruction. It's now going to write the prompts, and it generates a bunch of prompts for me, right? So now I've got all these alternative prompts, and then the last thing it does is it generates the tail, just like I said. So it says, please let me know if you have another task for which you would like me to write a prompt and create alternative approaches for. So right here, it's created a tail on its output. It's at the very end, and it says, please let me know if you have another task for which you'd like me to write a prompt and to create alternative approaches for. You notice that its sentence that it's created encompasses a lot of the rules. It encompasses enough of the information about what it's trying to accomplish that we don't have to worry as much that it's going to forget the rules. And so then I go and I give it another task. I say write a prompt to evaluate different prompts for summarizing the questions. And it goes through and it generates all the prompts, which we saw before. And then at the end, it generates the tail again. Please let me know if you have another task for which you'd like me to write a prompt and create alternative approaches. So we've got it to reintroduce the task again. And so now if we went in and we put in a new prompt, it still will remember what the context is. And if we went in and we had, back and forth without this, at some point it's going to forget the rules of the game. And it's going to say, hey, what am I supposed to do? Or it's going to forget to generate alternatives, or it's going to do something else. But by continually reintroducing the rules of the game as this tail on the output, then every time we go to send in a new input, just recently we had the rules of the game that give it the context that it needs to accomplish the task. So the tail generation approach is really, really useful when we're going to have a longer conversation, where we're going to try to program something. We're going to give it a bunch of rules up front, and then we're going to have a whole bunch of interactions, and we don't want it to forget the rules or the context. Now, it doesn't have to be rules. It could be anything that we think that needs to be reintroduced over and over into the conversation. And what we do is we just make sure that at the end of the output, we ask it to put in whatever that tail is. It could be asking for the next input. It could be, asking for some other additional information. It could be redescribing the rules. It could be kind of whatever you want it to be, but it's like a little nugget, a little tail that we're going to attach to that output to remind the large language model, here's what we've been talking about, and give yourself a little hint about it at the very end before we go on to the next task. Large language models really excel at working with text and understanding patterns of language. And a lot of times text is something that's really difficult to work with because we tend to have a human go and look at it to do a really good job of analyzing. Well, or we used to need a human to do that. Now we use large language models. But, going through and trying to understand text and manipulate text is one of the real strengths of the large language model. The next pattern is called the semantic filter. So this is basically a filter that can take in text and remove information from it, or only keep information that has certain meaning or has a certain qualities that we specify. And so this can be a really useful pattern for a variety of different cases. Now I'm going to show it in the case of taking text and filtering out or removing certain things that we would like to get rid of from those texts. This might be secret information of some kind. It might be, removing things that aren't public. It could be all kinds of different things, or removing redundant information, whatever you need it for. But this is kind of a useful pattern in taking and manipulating text. So let's look at an example of it. So I'm going to start off with a very simple example of the semantic filter. And I'm going to say, filter this information to remove all dates and rewrite the text as little as possible to fix issues caused by the date removals. And then I've pasted in some information about Vanderbilt University from Wikipedia. And in this information, there's a whole bunch of dates. And so I'm creating a complex filter that's going to basically take in information, it's going to remove all the dates, and it's also going to transform the information a little bit to rewrite it, just in case I'm removing a date and it sort of makes a sentence awkward, or there's obviously something missing. And so I'm going to take in information, I'm going to remove all the dates, and I'm going to slightly rewrite in order to do this. So I've got the Vanderbilt now Wikipedia information, and by using this pattern, which is to clearly say that you're going to serve as a filter, so we're going to say filter this information. So we're clearly indicating by saying filter that we want to preserve but remove. We're not trying to create new, we're trying to take in information and filter out or remove. So the pattern is basically, the semantic filter pattern is we're going to tell it to filter something, and we're going to give it sort of rules, semantic rules about the meaning and what we're trying to remove, the meaning or the purpose of what we're trying to remove. So then what it does is it goes through and it rewrites all the text, and you notice that it does a pretty good job. It removes all of the explicit dates. Now, one thing I noticed is that I might need to go and rethink my prompt and how to express dates, because it says founded in the 19th century. And that might be too specific for me, depending on what my meaning of date is. So I think it took a literal interpretation of it, like if it's, a specific date. So if you go back and look, it originally said founded in 1873. So it removed the date 1873 and replaced it by rewriting it with founded in the 19th century. So it's actually kind of removing information, but I asked it to rewrite, so it's transforming it a little bit. But this shows you kind of the power. It's understanding the text, it's understanding what a date is, it's removing it, and in this case, we're also transforming it to rewrite it in some way. Now let's show you a more interesting example, and kind of where the semantics and understanding of the meaning of things really gets used. So I'm going to say filter the information below to remove any information that would help someone figure out that the patient has diabetes. First, explain what information you're going to remove and how it might help someone figure out that the patient has diabetes. Then provide the filtered information. So what I've got below is a fictitious medical record that describes a patient, Jane Doe, has a number of symptoms. The patient presents to the clinic with complaints of increased thirst and fatigue for the past 2 weeks, history of present illness right here, past medical history down here, medications down here, allergies, a variety of things. And then I'm going to actually have ChatGPT go into a semantic filter on this information. So now let's take a look at what it's going to remove. So it says, well, the chief complaint of increased thirst and fatigue should be removed because increased thirst, polydipsia, is a common symptom of diabetes. The history of present illness mentions increased thirst and not checked her blood glucose levels, both of which should be removed because they are related to diabetes symptoms and management. The past medical history includes type 2 diabetes mellitus, and I apologize if I'm mispronouncing this, which should be removed because it directly indicates that the patient has diabetes. The medication metformin, 1,000 milligrams twice daily, should be removed because metformin is a medication commonly used to manage diabetes. So this is taking the semantics of, I want things that could give away that this patient has diabetes. I want them filtered out and removed, so I'm giving some semantic rules about what type of information to get rid of. It has to understand to some degree the meaning in the text, or at least know, based on its training data, that these are things that are commonly discussed around diabetes. So one way or the other, it's figuring that out. And then it goes through and rewrites the medical record. And notice it rewrites the chief complaint be to the patient presents to the clinic with complaints of fatigue for the last 2 weeks. The patient reports that she's been feeling more fatigued. She denies any recent weight loss, blurry vision, or infections. Past medical history is rewritten. The medication is rewritten. And so now we have a filtering of what was here before. And so we notice that, like the history, it removed this. The patient reports that she has been experiencing increased thirst for the past 2 weeks. So we can use these large language models to develop sort of powerful semantic filters using the semantic filter pattern. Now, is it perfect? No. As we've seen, there can be, issues with it. And as we've talked about before, they're not always perfectly repeatable. But as a starting point to help maybe support a human process that then looks over it a second time, or to try to help prevent accidental release, it's just one more check in the system. This is a fairly low-cost check to try to remove extra things. Should it be the only check? No. If we're going to filter things out, particularly for privacy or other reasons that are where we have information that we don't want to get out, we should always have other checks in place, because this is not going to be a perfect filter. It's going to have some randomness. It's going to not always do exactly what we expect, but as a part of another process, as a component to help, it's a very, very powerful technique that we could potentially employ in parallel or in conjunction with other checks, other types of removals. Thank you, everyone, for taking this course on prompt engineering. I hope that you'll feel inspired by all of the different examples to go out and really try to build interesting application using large language models. The thing I always want to emphasize in these discussions about large language models is the real power of these language models comes out through human creativity. If you have creative ideas, creative ways of using the tools, that's where you get really exciting outputs. A lot of the discussion we've seen is about bad outputs, and I just look at that as a failure in the use of the tool. You want to go and really try to be creative in how you use it. Come up with really great ideas. Find the problems that are really hard to solve using other approaches. And so I hope you'll be inspired like I am to really try to think about this tool. Again, I think of it as a tool for helping to quickly give my thoughts form, to do things faster and in unique ways that I couldn't do before. You know, as an artist in my earlier part of my career, I've always been excited about working in different mediums. You know, I could work in paint, or I could work in ceramics, or I could work with metal. And all of these different mediums have different unique characteristics to them. And I look at ChatGPT as another exciting medium for creativity, for coming up with new ideas and trying to give them shape, to give them form, just like I would in paint, just like I would in sculpture. So I hope you'll be excited to explore this new medium. And as one last final thing, I think it's always important to go back to ChatGPT and get its thoughts on what we should tell you as you leave the course. And so I think it's got some good points here. So I asked ChatGPT to act as the teacher of a course on prompt engineering, to thank students for being in the course and tell them about what they should do for next steps. And it's got some great points here. One, practice, practice, practice. I can't emphasize this enough. Really, a lot of the great things are going to come through you practicing and experimenting with ChatGPT or another large language model and asking the question, can I get it to do this? Wouldn't it be great if I could get it to do this? And a lot of times the answer is yes with some creative prompt engineering. So please practice, practice, practice. Stay up to date with the latest research and developments on prompt engineering. It's a very quickly moving space. If you go to arXiv, where we've listed some of the papers on prompt engineering there, you can find all of the latest updates. And I hope that you'll follow with what's going on and keep seeing all of the exciting discoveries that people are making. It's such a new space. Everybody can be at the forefront, riding the wave right now. And so I encourage you to do that. Collaborate with others. This is one of the things that I really enjoy about working with large language models, is there's so many people that are just as excited as I am. And when we get together, we come up with crazy ideas. Well, what if we did this? What would it look like if we had them talking to each other? What if the large language models were talking to each other? What would we do differently? Or how would they, word things differently? There's all kinds of fascinating ideas, and those ideas really come out through collaboration and also from just looking at what different people are doing, how they're sort of approaching prompt engineering. So I encourage you to collaborate with others. And then finally, to keep ethics in mind, there's a lot of the discussion around ethics with these models. And I think it's really important, particularly as the early sort of adopters of this technology, that we use it in an ethical and appropriate way, that we show all of the good things that can be done with it rather than showing bad things. If we keep adding to the negativity around these models, what we're going to do is we're really going to dissuade people, and we're going to have people miss all of the wonderful opportunities to do interesting and creative things. So please, please, obviously keep ethics in mind. So I think this is a great wrap up from ChatGPT. Again, thank you so much for participating in this course. I hope you'll be engaged in the discussion forums. I hope you'll keep sharing prompts and interesting ideas that you have with the community and around this course. And again, I can't wait to see what everyone in this course does with prompt engineering and all the amazing things that you create.